This is the webcast by Iga and Daan. We'll be talking about indifference curves and their properties. The definition of an indifference curve is it is a set of bundles among which a consumer is indifferent. And a bundle is a particular combination of two products. As indifference curves are about consumer preferences, they're a graphical representation of consumer preferences. This is also something that you'll see later in the exercises. So this is how a general indifference curve would look like. The blue line is the indifference curve. All the points on the blue line represent a bundle. So for example, point D is the combination of 25 shelter and 6 food. All the points on the indifference curve are points where, as I said before, the consumer is indifferent between. But for example, if you would see point L over here, you see it's above the indifference curve, which means the consumer would prefer point L to any point on the indifference curve. The same accounts for point K, but then it's the other way around. Since it's below the indifference curve, the consumer would prefer the points on the indifference curve over point K. Important to see is that it's always about a quantity within a given time if you would graph indifference curves. This is because consumer preferences can change over time. So as they are a graphical representation of consumer preferences, we will go a little bit into consumer preferences. Generally, economists assume 4 properties of consumer preferences: completeness, more is better, transitivity, and convexity. Completeness means that a preference ordering is complete when it enables a consumer to list all possible combinations of goods and services, which is to prevent situations in which a choice cannot be made. This, of course, is very hard to obtain a list of all the preferences of consumers. However, for the sake and simplicity of the model, this is generally assumed. More is better. With other things equal, more of a good is preferred over less. This is something that most people would generally assume. But of course there are occasions in which, for example, if you've overeaten, you don't want any more food. That's not the case, but again, for the sake of the model, this is an assumption. An example would be if you have 2 bundles, bundle A and bundle B. Bundle A consists of 1 TV and 1 DVD, and bundle B consists of 1 TV but 2 DVDs. You would prefer bundle B over bundle A because more DVDs is better. Transitivity. If one prefers A over B and B over C, one prefers A over C. This is something most people would deem logical, and it's useful because if this would not be the case, one would enter a vicious circle of trading and keep trading forever, because one would simply not have one bundle which it would be preferred over the others. Then the last one, convexity. This is about the fact that mixtures of goods are preferred to extremes. An example would be if you're indifferent between 2 bundles, one consisting of 0 and 4 of the products and one of 4 and 0, you would prefer the bundle which has 2 products of both. This is because in the cases of extremes you have a lot of one product and not that much of the other product, or completely nothing of the other product, and it's generally assumed that consumers prefer a bundle in which they have a little bit of both. That's it. Exercises. Question 1. Economists generally assume that consumers' preferences satisfy 4 properties. Please list these properties. The correct answer to this question is completeness, more is better, transitivity, and convexity. Question B. Indifference curves maps generally show the characteristics that imply the 4 properties of preference orderings, one of which is a diminishing slope, as seen in the graph below, due to a diminishing rate of substitution. Which property is implied by the diminishing rate of substitution? This is the convexity property of preferences. This entails that averages are preferred to extremes. At the top of the curve you have an extreme bundle, so the willingness to trade a lot of the good on the y-axis, which you have a lot for, here at the top, for a good on the x-axis is high, since averages are preferred. This also happens as we move further along the x-axis, as one becomes less willing to trade y for x, since one would then move again to an extreme bundle, but then with a lot of good x instead of a lot of good y.
In this part of the webcast, I will be talking about how to draw indifference curves. As previously mentioned, indifference curves may be represented graphically. The shape of indifference curve depends on the type of good that is being represented. For normal goods, the indifference curve will have a shape of literally a curve. In order to draw that, you need to draw a curve which touches consumer bundles, which will then result in the indifference curve showed right here on this graph. For goods which are perfect substitutes, the indifferent curves will take a shape of straight line because the consumer does not care whether he consumes Pepsi or Cola, as he likes them equally and gets the same total utility from both. For goods which are perfect complements, the indifferent curves will take a form of a line broken by a 90-degree angle. The reason for that is that if goods are perfect complements, one is useless without the other, which can be seen on this graph. Exercises, question 3. Consumer has a weekly budget of 100 euros. He spends it on food and shelter. Sketch an indifferent curve for food and shelter given that A. Food and shelter are normal goods. B. Food and shelter are perfect substitute. C. Food and shelter are perfect complements. D. He likes food but not care about shelter. A. Food and shelter are normal goods. As you can see in this graph, you can see consumers' bundles. Across these bundles, you need to draw a curve that will touch them. And this will be the indifference curve for normal goods. B. Food and shelter are perfect substitutes. As mentioned in the theory part, the consumer does not care whether he will consume food or shelter because they will give him the same utility. This is why I will draw straight lines as the indifference curve. And this would be the indifference curve for the perfect substitute. C. Food and shelter are perfect complements. As mentioned in the theory part, if two goods are perfect complements, one is useless without the other. Thus, the shape of the indifferent curves will look something like this. And that would be your indifferent curves for perfect complement. D. He likes food but does not care about shelter. In this case, our indifferent curves will take a form of a horizontal line because as the line goes up, his satisfaction for food grows because that's what he cares about, but stays the same for shelter, which is okay because he does not care about shelter. This was the webcast by Iga and Daan. Thanks for watching.